Hello again. So this is our question in which we are going to discuss the previous question, which was assessment problem 4.2. So the same question we are going to solve by using another method, which is called the mesh current method. So why is this method called the mesh current method? Because in these type of questions, we can select the meshes in a circuit, and in each mesh we have to apply the Kirchhoff's voltage law. Just like in the previous method, which was node voltage method, we had to select the different nodes in a circuit and apply KCL over each node. So now this technique is somehow different, in which we have to find the voltages in each mesh of a circuit. So why we are going to do this method? Because if you find this method feasible for a certain circuit, you can apply this one. Otherwise, if the other one is feasible, you can apply that one. If in each question you are asked to use whatever method you like, so you can use this or that method, mesh current method or the node voltage method, whatever you feel is feasible for the scenario. So now here, in order to use the mesh current method, what we have to do, we have to select the meshes here. So in this circuit here, we have three meshes. The first one is this one, second one is this mesh, and the third one, let me write by using the blue one, this is the third mesh. So this is one, this is, sorry, let me use the same colors here. So this is one, mesh number one. Mesh is basically the closed path here. This is in green, this is mesh number two, and this one in blue is the mesh number three. So in each mesh we have to select each mesh, and in each mesh we have to consider is the current. So in mesh one, let us consider the current. Let me consider the current, which is, let me call it I1. Okay, in mesh 2 I am considering the current which is flowing the clockwise direction. So this is, let's say, I2, and in mesh number 3 I am considering this current which is I3 and with the same direction here. So now, considering each mesh here, let me consider the mesh 1. Okay, so in mesh number 1 we have to apply the KVL. Okay, so we have to apply the KVL, but wait a minute, there are basically two elements here, and we have to find, in each mesh we have to find the value of I, the current. So if this is I1 and this is the branch in which I1 is flowing, so we know I1 already. Okay, so the value of I1 is 4.5, because in this branch the value of I1 is already given. So now the value of I1 is already found out. So that is basically I1 is 4.5 amperes. Okay, so we have found out, it is already given. So now let us go towards mesh number 2. In mesh number 2 we have different elements, this one, this one, this and this one. These are basically the three elements. So the voltage across this one, and we have to add them. Let us add them, because these two are in series. So the applying KVL here, applying KVL in mesh number 2, we will get voltage developed across 1 ohm plus the voltage across 6 plus 2. These two are in series, so let me call it V8, and the voltage across 12 ohm, the sum of these voltages should be equal to 0. This is the statement of the KVL. So now what is the value of V1? This V is always equal to IR. This is according to the Ohm's law. So the value of the R is given, which is 1 ohm, but what will be the value of the current? So the current here will be the difference between the current in this mesh minus the current in the other mesh. So here the voltage here will be 1, which is the value of resistance, multiplied by the current in this mesh minus the current in the other mesh, or the difference of the currents which are flowing in any branches. Okay, so this is the I2 minus I1. Similarly, when we are considering this 8 ohm resistor, so here we have only one resistor, which is the summation of 6 and 2 ohm. So 8 multiplied by the current which is flowing through these two resistors, so only one current is flowing through them, that is I2. Okay, and similarly V12 is the resistor, and what is the current? Current is again the difference between the current which is in this mesh minus the value of the current in the other mesh. So it will be equal to I2 minus I3. This would be equal to 0. So let me simplify it. It will be equal to I2 minus I1 plus 8I2 and plus 12I2 minus 12I3. This is equal to 0. So do we know the value of I1? Yes, we do, because it is already given here. So the value of I1 is 4.5. Let me put it here. So I2, this I2, let me add them again. The I2 plus 8I2 plus 12I2. This is let me solve it in a single step. So this will be equal to 8 plus 12 plus 1. This is 21 I2. Similarly, this is minus 12 I3, and the value of this one, which is minus 4.5, this is equal to 0. Moving it to the other side, we will get 12I2 minus 21I2 minus 12I3 is equal to 4.5. Similarly, simplifying them here, by simplifying them we have to take 3 common. So by taking 3 common here, 7I2 minus 4I3 is equal to 4.5. so dividing both sides by 3, we will get 7I2 minus 4I3. 4.5 divided by 3, this will be equal to 1.5. so let me call it equation number 1. So this is the equation of mesh number 2. So similarly, going towards the mesh number 3 here, so this is mesh number 3. so now let me consider it here, mesh 3, and again apply KVL here. Applying KVL here, again we can see that there are basically 2 resistors here. So the value across 12 ohm resistor plus the value across voltage value across the 4 ohm resistor plus the 30 volt voltage source, this should be equal to 0. so this value will be equal to the value voltage value which is across this 12 ohm will be equal to the value of the resistance multiplied by the difference between the current. So I3 minus I2 is the current. Similarly, only one current, which is I3, which is flowing across this 4 ohm resistor. So that is I3 plus 30. This is equal to 0. Okay, so now simplifying it, 12I3 minus 12i2 plus 4i3. Moving this 30 to the other side, we will get minus 30, or this will become minus 12i2, adding these two terms together. Now adding these two terms together, 12i3, 4i3, we will get 16i3. This is equal to minus 30. Simplifying them again by taking 4 common here, so here we will get 4, and this will become minus 3i2 plus 4i3. This is equal to minus 30, or dividing both sides by 4, we will get minus 3i2 plus 4i3 equal to minus 7.5. so this is our equation number 2. So we have found out these two equations, and by finding out the solution of these two equations, we will get our required currents which are in each mesh here. So let me proceed here. So now we have two equations. One is the 7i2 minus 4i3, this is equal to 1.5. this is equation number 1. Similarly, the other equation is minus 3i2 plus 4i3, this is equal to minus 7.5, which is the equation number 2. so let me add them together. So okay, adding them together, what will we get? These two will cancel out, and here we will get 4i2 is equal to here minus 6, or the value of i2 will be equal to minus 6 divided by 4. So this is almost equal to minus 1.5. yes, this is minus 1.5 amperes. This is the value of i2. okay, similarly, when we put the same value in our equation, which is equation number 1, let me put the value of i2, putting i2 equal to minus 1.5 amperes in equation number 1. So when we will put it, we will get i3 equal to minus 3.22 amperes. okay, so this is our quantity number 2. this was our quantity number 1, which was here i2. so we have found out our values here. So now we have to find out this v, which is the current between this and this point. So as we find out last time, the value here, this v is, let us call this one as v12 and this one as v0. so let me go down here again. So the value here, this v0 will be equal to, or this small v, this small v is equal to the v12 minus v0. so the value of v12, as we earlier know that the value of v12 is this one. This is the i3 minus i12. okay, or similarly here the value here was the i2 minus i3. okay, so considering any one of these, so let me use the other one, i2 minus i3. And similarly, the value of v0 is how much? The value of v0 is this 2 multiplied by i2. okay, so this is the value which we have to use here. 2 multiplied by I2. Okay, so now let me put all the values here. 12 I2, what is the value of I2? Value of I2 is minus 1.5. The value of this is minus plus, so minus 3.22. Similarly, the value of it will be minus 2 multiplied by the value of I2 is 1.5. so when we find out, we will see this, that by solving this equation or by calculating all the terms here, we will see that the value of V is 15 volts, which is same as we find out by using the node voltage method. So both the method has given us the same answers for the quantity, but the only thing here you have to consider is the complexity of each method, which one is feasible for a certain circuit and which technique is not feasible for you. So you can choose any of the method, unless you are not given that use the following method or use the other method. So you can choose any one of the techniques which we have seen in our last 2 videos. So that's it, and we will solve more questions in our upcoming videos. Till then, thank you so much and take care.